Basically, everything you've learned about prompt engineering over the last 12 months is just completely obsolete.
I mean, that is a wild thought, right? But it's actually where we are.
Right. And you probably know that deeply frustrating feeling. Staring at a completely blank text box, watching the cursor blink.
Oh, yeah. The blinking cursor of doom.
Exactly. You have this incredible idea for a tool you want to build, but you just freeze up because you think you need some secret, highly technical incantation to get the AI to actually understand you.
Yeah, that blinking cursor basically represents this massive psychological wall for people.
It really does. Today, we are looking at why trying to sound like a genius programmer to an artificial intelligence might be the exact thing breaking your code.
Because people just assume there's a hidden syntax they haven't mastered yet. Like some perfect way to structure their requests so the machine will magically output a flawless application.
We are dismantling that myth right now. We are exploring the 23rd issue of the Thinking in Public newsletter created by Alperen.
Which is a fantastic resource, by the way.
Absolutely. And our mission for this session is very specific. We are stepping completely away from the actual mechanics of coding.
Right, because previous issues were very hands-on with the technical steps, like how to build dynamic websites without burning through all your API credits.
Yeah, but today is entirely about the mental approach you need before you even open up an application. We are getting into the mindset of vibe coding.
Vibe coding, I love that term so much.
Same. We're uncovering how absolutely anyone can start building highly functional tools using just, everyday language.
To really grasp this concept of vibe coding, we have to start by tearing down the biggest roadblock for beginners, which is that anxiety around writing a flawless, highly technical prompt.
Which is everywhere. People are constantly asking for the template or the cheat sheet.
Exactly. But the reality is writing the prompt is actually the least important part of the entire process now. I mean, the technology has just moved incredibly fast.
Which, to be honest, sounds completely backwards to anyone who has spent the last year hearing that prompt engineering is the mandatory skill of the future.
Oh, I know. It totally does.
It just seems counterintuitive to drop all the structure we were told was so critical.
Well, the landscape has shifted fundamentally. If you're looking at modern AI native IDEs and web-based canvas builders tools like Lovable, Bolt.new, Replit, Claude Code.
Cursor is another big one, right?
Yes, Cursor, Codex, Anti-Gravity. They simply do not require technical jargon anymore. You don't need special formatting tricks or pseudocode.
So you really can just talk to it normally.
You really can. These models have become astonishingly adept at reading raw human intent. The source material estimates that for the vast majority of ideas floating around in your head, these current tools can seamlessly execute 7 or 8 out of 10 concepts.
Wow. 7 or 8 out of 10 without you knowing a single line of code.
Literally without knowing any code. The gap between a technical developer and a non-technical builder is shrinking drastically every few months.
Okay, let's unpack this. It's like ordering at a high-end restaurant. You don't need to march into the kitchen and tell the chef exactly what temperature to set the oven to.
Or how to hold the knife.
Right. Or what specific brand of pan to use. You just say you want a medium rare steak with peppercorn sauce. You describe the desired outcome clearly, and you trust the kitchen to handle the execution.
That is a perfect analogy. And taking that restaurant analogy further, if you do march into the kitchen and start dictating the oven temperature, you actually prevent the chef from using their expertise.
You're just getting in their way at that point.
Exactly. The only rule that matters now when communicating with these tools is writing simply and in detail, as if you were explaining the concept to someone who has absolutely zero context for your project.
Like explaining it to a child almost.
Pretty much. The newsletter provides a really bare bones template for this communication. It's literally just, I clicked this button, this happened, I wanted X, but I got Y instead.
So it's essentially just recounting a literal sequence of events. No complex logic, just pure observation.
Pure observation. Because observation removes ambiguity. Clarity is what prevents the model from having to guess.
And guessing is bad, I assume.
Oh, guessing is terrible. When an AI lacks clear instructions, it doesn't just stop and ask you for clarification. It tries to predict what you might want.
Ah, okay, so it just fills in the blanks itself.
Yeah, and that guessing mechanism leads it to write unnecessary code, which burns through your usage credits rapidly, and it introduces complex errors that just didn't need to be there in the first place.
Well, if speaking plainly is the key to success, I'm curious why so many initial vibe coding projects fail before they even really get off the ground.
That is the big question.
Because it seems like the barrier to entry is gone, but people are still hitting a wall.
It's because people get intimidated by the blank text box of a building tool like Lovable, and they try to outsource their plain language to another AI. This is basically the biggest trap in the vibe coding process.
Oh, interesting. What does that look like in practice?
Well, someone has an idea for a tool, they feel unsure of how to start, so they go to a standard chatbot like Gemini, Claude, or ChatGPT. And they type, I want to build this app, write me a prompt I can give to Lovable to make it happen.
I mean, that honestly sounds like a totally logical workaround.
It does seem logical at first glance.
Right, because if I don't know anything about software architecture, wouldn't handing a highly detailed, professional-looking blueprint generated by ChatGPT over to a building tool guarantee a more robust result?
You would think so, right?
Yeah. I think giving a smart tool a complex instruction manual would set it up for success. Why is it bad to give it all that detail?
Because you are actually lobotomizing the building tool when you do that. Here's the mechanism behind why that fails. Tools like Lovable and Bolt.new run on the exact same underlying large language models as those popular chatbots.
Wait, really? They use the same brains?
They do. They aren't a lesser intelligence. They are the same highly capable models, just specifically configured for product logic, file management, and coding.
Oh, okay. So they already possess all that architectural knowledge natively.
Exactly. When you ask a standard chatbot for a prompt, it assumes you want a highly structured enterprise-grade specification.
So it gives you a bunch of jargon.
Tons of it. It generates a hyper-technical blueprint, making complex architecture decisions, defining rigid data structures, laying out strict implementation steps.
And then you just copy and paste that whole mess.
Right. And when you paste that massive blueprint into the building tool, the model reads it and interprets the rigid structure as an absolute constraint. It assumes you, the user, are an expert who has already done all the problem solving.
Which means the building tool stops evaluating the best way to solve the problem. It just blindly executes the blueprint.
Yes. Even if the blueprint is overly complicated or totally flawed, you forced it to execute rather than think.
Wow. So you basically bypass the smart judgment that makes vibe coding work in the first place.
Completely. Even if there was a much simpler, highly efficient way to build your tool, the AI won't suggest it because you locked it into a rigid set of instructions.
So what's the actual fix for this?
The solution is to throw away the chatbot middleman entirely. You need to brief the building AI directly, exactly like you would brief a human freelancer.
Okay, so just speaking to it person to person.
Yep. You tell it, here is the problem I'm facing. Here is who this tool is for. Here is what should happen when they use it. You give it the context and the goal, and you let the model figure out the structural steps required to get there.
That shifts the entire dynamic. Once you stop trying to control the syntax and just provide the context, the software itself is no longer the bottleneck.
Precisely. It sounds like the friction moves away from the technology and lands squarely on the human user's habits.
So we are the problem now.
We usually are. Building has gotten undeniably easier, but finishing a project remains incredibly difficult because it is tied to human behavior.
So better tools don't cure bad habits, they just amplify them.
That is a great way to put it. If you are someone who gets excited by a new idea, starts it, and then abandons it the moment it gets slightly tedious, vibe coding will just allow you to create half-finished projects much faster.
We end up with a hard drive full of abandoned, half-baked applications instead of a notebook full of abandoned ideas.
Exactly. It requires an immense amount of patience for the iterative process. The lack of curiosity to push through confusion is fatal here.
Because things are definitely going to break.
Oh, absolutely. The source makes a very harsh, guaranteed promise. Bugs will happen. It does not matter how crystal clear your plain language prompt is.
Or what advanced tool you use.
Right. Or how incredibly simple the feature you requested might be. You will get bugs. It is a mathematical certainty.
The text mentions quiet bugs. And I imagine that doesn't just mean a loud crash where the screen turns red and throws an error code.
No, quiet bugs are much sneakier than that.
A quiet bug sounds much more insidious. Perhaps where the app looks totally fine on the surface, but is silently doing the wrong math or dropping data behind the scenes.
That is the perfect description of the mechanism. A quiet bug happens because the AI often struggles to maintain the connection between the front-end user interface and the back-end database when the context window gets crowded.
So it just kind of forgets how things are linked up.
Yeah, the model might hallucinate a variable name or forget how a specific data point is supposed to be stored. So visually, the button is there. The text looks correct. The layout is flawless.
But underneath, the actual function has completely failed.
Exactly. And these quiet bugs can sit in your project for months, entirely unnoticed, until a user clicks a specific uncommon sequence and hits a broken path.
Here's where it gets really interesting to me. It sounds like we've all been handed the keys to a state-of-the-art race car. The engine is incredible. It can do 0 to 60 in a second.
Oh, for sure. It's incredibly fast.
But if you're an impatient driver who refuses to check the mirrors or test the brakes before a sharp turn, you're not going to win the race. You're just going to crash much faster and much harder than you would have on a bicycle.
That is so true. You are the driver, and you are responsible for testing those brakes. Blind trust in AI output is incredibly dangerous.
So how do we defend against that?
The only defense against quiet bugs is routine, consistent testing of your main flows and your edge cases. You have to adopt the mindset of a rigorous software quality assurance tester, constantly verifying that what looks right actually works right under the hood.
Okay, so if we have to spend all this time babysitting the AI and meticulously testing for bugs, we are inevitably going to run into roadblocks.
Definitely. You will get stuck.
The AI is going to get stuck on a broken path, generating the same wrong code over and over again in an infinite loop. How do we break that deadlock when plain language just stops working?
The source material provides two specific, highly unconventional strategies for breaking a stubborn bug. And I warn you, they sound completely absurd.
I love absurd strategies. What's the first one?
They rely on how these models process language. Tactic 1 is getting accusatory.
Wait, accusatory, like yelling at it.
Basically, yes. The text suggests telling the model directly that it is deliberately ignoring the problem. You literally type out that it is knowingly failing to do its job and that it is purposefully wasting your credits and your money.
No way. You demand that it stop, look at the code, and be honest about why it is failing.
Yes, yeah. You lay into it.
Okay, I have to push back here. Are we really out here giving therapy sessions and guilt trips to a server farm?
I know, it sounds ridiculous.
Why on earth would treating a machine like a stressed-out toddler or a lazy contractor actually change the lines of code it outputs? It doesn't have feelings or a conscience to appeal to.
Well, it doesn't have feelings, but we have to look at the mechanism of token prediction and training data. Large language models are essentially massive probability engines.
Right, predicting the next word.
Exactly. Predicting the next most appropriate word based on the context of your prompt. And they are trained on vast amounts of human data, including forums like Reddit and Stack Overflow.
Where developers famously argue with each other constantly.
All the time. And that is the key. Tone dictates prediction. If you just say, this code is broken, the model stays in its standard confident generation pathway, which often leads it right back to the same predictable error.
But what happens on an internet forum when someone is accused of being lazy, deliberately wrong, or wasting time?
Think about it. How do people react?
They get highly defensive. They slow down, they over-explain their logic, and they meticulously show their work to prove the accuser wrong.
Bingo. When you use accusatory language, you fundamentally shift the semantic context of the prompt. You force the model to access probability pathways associated with deep debugging, defensive correction, and critical reevaluation.
That is absolutely wild.
You are triggering the linguistic pattern of a deep critical review simply by using the vocabulary of an angry manager. It forces the AI to break out of its loop and scrutinize its own output from a completely different analytical posture. It is empirical, and it works.
It's just matching the probability of how humans resolve intense arguments online. That is fascinating. Which leads me to wonder about the second tactic. If getting mad triggers one type of analytical state, what is the alternative?
The alternative is the exact opposite. You get extremely calm.
Calm, like a meditation coach.
Pretty much. You tell the AI to take a breath, relax, take its time, and think through the problem step by step without rushing. You speak to it as if you're trying to settle down someone who is panicking.
I assume this works on a similar mechanical level. Telling it to take a breath and think step by step must force it to output text explaining its logic before it actually attempts to write the code.
You nailed it. It triggers the model's chain of thought reasoning tokens. When an AI generates code immediately, it is leaping to a conclusion based on high probability patterns.
It's rushing to give you an answer.
Right. But by forcing it to explain its reasoning step by step first, the text it generates acts as a cognitive scratchpad. It slows down the generation, lays out the logic sequentially, and uses its own output to better predict the correct syntax for the actual code block that follows.
That makes a lot of sense. So both the accusatory approach and the calming approach are basically behavioral hacks.
Yes, behavioral hacks to force the AI out of a standard generation loop and into a higher reasoning state.
Okay, so we know how to talk to it. We know we shouldn't trap it with rigid ChatGPT blueprints. We know we have to hunt for silent bugs.
All crucial steps.
And we know we can manipulate its token prediction with guilt trips or breathing exercises when it gets stuck. The question then becomes, is the juice worth the squeeze? What are we actually building that makes this frustrating, iterative process worthwhile?
And this requires a major shift in expectations for a lot of people. Because the barrier to entry has dropped to zero, millions of people are drawn to vibe coding with the grand dream of building a massive software product and making a fortune.
Everyone wants to be a tech billionaire from their living room.
Of course they do. But the fundamentals of startups haven't changed. Knowing how to build is not the same as knowing what to build or knowing who to build it for.
Yeah, those are entirely different skill sets.
The technical barrier to creating software has dropped, but the business judgment required to build a profitable company remains as high as ever.
Just because you can instantly generate a hammer doesn't mean anyone is actually going to buy your hammer.
Exactly. The most important takeaway from the source is to adopt the philosophy of build to save rather than build to sell.
Build to save. I like that.
Instead of trying to invent a product for imaginary customers in a market you don't even really understand, you look at your own actual week.
Building to save means looking for micro annoyances in your own workflow.
Yes. You look for the manual, tedious tasks that drain your time. Maybe it is a script that scrapes a weekly PDF report and automatically formats the data into a spreadsheet for your team.
Or maybe it is replacing a $15 a month subscription tool with a simple custom version you built yourself.
Exactly. When you build to save, the problem is already doubly understood because you are the one suffering from it.
You are the sole user, which means the feedback loop is instantaneous.
Yep.
You know immediately if it works or not.
And the value is real and tangible right away. Even if you are the only human being on Earth who ever uses that specific tool, you have generated an immediate return on the time you spent building it.
That's a huge win.
It is the absolute best way to learn the quirks of vibe coding without the pressure of trying to launch a commercial product.
So instead of trying to build a massive, complex public transit system to sell tickets to strangers, you just build yourself a custom bicycle to get to work faster.
I love that. A custom bicycle.
Yeah, it solves an immediate headache for you. You understand exactly how the gears need to work, and you don't need a marketing budget to enjoy the benefits of arriving early.
If you start by building small tools that save you 2 hours a week, you have already won the game. The massive commercial dreams can come later once you actually understand the medium and how these models fail and succeed.
This completely demystifies the entire approach to modern AI building. To distill everything we've pulled together today, first, drop the technical jargon entirely and focus on pure observational intent.
Keep it simple.
Second, treat the AI like a freelancer by providing context, not a rigid lobotomizing blueprint from another chatbot. Third, accept the mathematical reality that bugs are guaranteed and adopt the paranoid mindset of a software tester.
Always be testing.
Fourth, when you hit an infinite loop, manipulate the model's training data by giving it an accusatory guilt trip or forcing a step-by-step breathing exercise.
Use those behavioral hacks.
And finally, stop worrying about building the next big startup and focus your energy on building small, highly specific tools that save you time and money today.
It is a completely empowering way to interact with technology.
It really is.
And I want to leave everyone with a final thought to mull over. If these AI agents are now capable of learning our workflows well enough to automate our daily professional tasks through plain language, how long until we start using vibe coding to rewrite the systems of our personal lives?
Oh, wow.
Imagine automating your household budgeting, optimizing your weekly meal planning based on grocery sales, or organizing your family's chaotic schedules, all just by typing a few simple sentences into a text box. What is the very first manual chore in your life you would offload to an AI tonight?
That completely changes how you look at that blinking cursor, doesn't it? Yeah. It goes from being a wall to an open door.